All right, so to conclude our three-stage polar bear model, um, we'll talk a little bit about linearity and non-linearity. So we discussed time series already a bit, but let's consider this sort of a situation where you have the blue line is one variable and red line is another variable. And in this case, they really have a very strong correlation because when one goes up, the other goes up. When one goes down, the other goes down, and so forth. And in this situation, there's quite a lot of blue going up and red going down, or red going up and blue going down. So in this situation, you would probably see a very strong negative correlation, and you would conclude that these two things are really have some that one stops the other one from happening. And then in this final situation, there is really nothing much to see. There's not really a great pattern here. So the blue line flatlines at some points, and at some points they go together. At some points they go apart, and so forth. But here's the twist. These are actually three snippets of the same time series. So these are actually the same two variables happening in being connected in all of these three situations, and they are actually causally connected. So if you would take a correlation out of all of this time series, you might see some weak correlation, or you might see a zero correlation, but you wouldn't conclude that there is some causal connection, although we know that there is one because they are actually very simple mathematical equations that are built so that they have this causal nonlinear dynamic coupling. And this produces a kind of a dilemma. So, if because we know that these sorts of nonlinear coupling processes are very common in nature, and we also know that correlation is a measure that only takes a very particular relationship into account. So when one thing is above its average, the other thing is above its average, or and it sort of tallies those crossings of the average between these two variables. But this thing doesn't go away if you take Spearman correlation instead of Pearson correlation. And I have a blog post about that. It's called Correlation Pitfalls. If you go and look at my blog, so I provide some alternatives. I talk about mutual information, for example, but it might be interesting if you're into that sort of stuff. But the basic point I wanted to make here is that correlation might not actually tell you what you want to know, because you want to know whether these two things are connected, and correlation only tells you if they're connected in this very particular way. And we can also think about nonlinearity in terms of these dose dependence curves. So almost all these if you have something that you can take in as a dose. So here we can think of physical activity. So on the horizontal axis, we have exposure, so the dose, and the health benefit on the vertical axis. And just built this out of a model. It's just for pedagogical reasons, but you can think of this as an example of physical activity or whatever tickles your fancy. And you can very much see that here, if you want to know, okay, so what's the benefit of physical activity? you need to define the benefit for whom. Because for these guys, if you draw an eye here and an eye here, you remember those lectures about convexity that we had. We can see that, okay, so a person in this situation has actually much more to gain from physical activity, from increasing their physical activity, than a person in this portion of the curve. So this is the convex portion, and this is the concave portion. So you again draw the eyes here and here. And if you didn't get that, go back to the section on convexity and evidence-free decision making from earlier. But there's also the thing that if you were to increase physical activity indefinitely, then eventually you would die. And so this is it is what it is. So anything so the devil is in the dose. Anything good is only good up to a point, and anything bad is only bad if taken to an actual excess. There is a nice paper about this in from 2023. It's quite technical, but you can skip the math if you want. And also the book Anti-Fragile. If you remember, we were talking about complex systems, and we talked about how you can actually do the same thing again and again and expect different results. So that's my one of my experiences with this book. So I've read it or listened to it with the audio version many times in different life situations, and it's always given me some new perspective on how to view these things. And we also did this nonlinear relationship when we think about, okay, so are the magnitudes of events actually the same as the effect of the event? So do we need a big event to get a big effect? And if you have a linear map of the world in your head, you think something like this happens. So you put in a little effort and you get a little result, and you put in medium effort and you get medium result, and you put in maximum effort and you get maximum result. And if you have this sort of a linear idea of how the world works, then you might be discouraged if you're in if the actual situation is something like this. So you put in effort and nothing happens, and you put in more effort and nothing happens, and nothing happens, and nothing happens, and nothing happens, until everything starts happening at once. So very little increases in effort produced greater and greater result. But of course, you won't see this part of the curve if you have this model. You expect to see this, and you get discouraged because you think that, okay, so well, I'm just doing things wrong because nothing's happening. And this is the same learning curve with these methods of analysis and dealing with data, that for a very long time it does feel like you're not understanding shit, and for a very long time people feel very stupid. But at some point you actually start seeing these things everywhere and understanding them in this very nonlinear fashion. So I implore you to not give up. And another consequence of having this sort of a linear map where events and their effects should be proportional is the proverbial breaking of the camel's back. So you put in a straw, you put in the next straw, nothing happens. So you figure, oh, you're probably safe. And then at some point you put in the last straw, the back breaks, and some social scientist comes running in and start studying that last straw and what was the spectacular backbreaking abilities of that particular straw, which is of course lunacy, because it was never the straw, it was the accumulation of stress and reaching a threshold or a tipping point, which we will come to next. But so this is sort of very can be very damaging if you're, for example, a decision maker making decisions about climate change mitigation, for example. So you think that, oh, well, a little more, there's so much CO2 in the atmosphere. What harm could it do to just put a little more in? And or I've already had COVID a few times. What problem can there be if I just have it a couple times more, or let everyone in the world have it many times? And so this is sort of the difference between the map and the terrain. And having a sort of map in the world of the world, and thinking about and mixing it up with the actual world. And this tends to produce these black swans that we talked about, which are of course not black swans to everyone, but just the person who had the wrong map.